everyone, welcome back to this channel. We are studying class 10 science, in that physics, that is chapter 12 electricity. Now in the previous videos we have covered up to Ohm's law and we have seen various concepts related to Ohm's law. Now we are going to study in this video about resistance and resistivity. So we are going to continue what from where we left. Now look at this one. We will have a shortcut trick related to that Ohm's law, that V equals to IR, that we know. But here in this formula you can see three different physical quantities are related. V, that is potential difference, I, that is current, R, that is resistance. So whenever we want to find out any one out of these three, what you have to do, you have to just remember this triangle, that is VIR. Over here you can see. Now the rule is, whatever thing that you are finding, whatever physical quantity that you are finding, you just have to cover it up and the remaining will be like this. Top to down, if anything is remaining, then you have to divide. Right to left, if you have to right to left it is remaining, then you have to multiply. For example, let us see here. Let us find V, right? So cover V, I and R is right to left, so multiply. If you want to find out I, that is V by R, and if you want to find out R, that is V by I. So this is the simplest trick. By using this whole triangle, you can find out these three physical quantities, right? Because as per the requirement in the numerical, we have to change the formula. That is why we have to use this trick. Now moving ahead, let us see what is next. We have example related to Ohm's law, and the example says how much current will an electric bulb draw from a 220 volt source if the resistance is 1200 ohm. So this is the first case, and again now if there is 220 volt potential difference and now the resistance is 100 ohm, what will be the current? So let us see this numerical solution step by step. You see there are two cases in this equation. First case is V equals to 220 volt, R equals to 1200 ohm. So we know that I equals to V by R. Now putting the values, V was 220, R was 1200. So 220 upon 1200 will give you 0.18 ampere current. Now let us move on to the second case. In the second case, V equals to 220 volt, R equals to 100 ohm. So now applying the same formula, I equals to V by R, putting the values 220 upon 100, that will give you 2.2 ampere current. So this was very easy. Now let us move on to the next question. The next question says that potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. So voltage, potential difference and current is given. Now the second case, what current will the heater draw if the potential difference is increased to 120 volt? So there are two cases. Again, let us use this case 1 to find out the answer of case 2. Now in case 1, what is given? You see, voltage is given 60 volt, current is given 4 ampere, nothing else is given. In case 2 also, you see 60 volt will be given and we have to 60 volt is converted into 120 volt and then we have to find out the current. So lots of things are missing. Which one is the first? That is, we don't know what is the value of R. So from help of case 1 we will find R and then we will utilize that R value to find out the current in case 2. Let us see how it is done. So V and I is given, we are finding R. We all know R equals to V by I. So that is 60 upon 4, 15 ampere. Right. Now for second case we got the value of R. So let us start case 2. Now the voltage is increased to 120. Current we are finding R. From the first case we have already found 15 ampere. So utilizing the formula I equals to V by R, this is 120 upon 15, that is 8 ampere current. So these type of questions are very easy if you remember the formula. And if you remember or if you make the given list, this will be very easy. Now, reviewing the concept of resistance that we have studied in Ohm's law, we will go further in this resistance topic. Now you see, this is a very small part of a conductor in which you can see the electrons are flowing, but you can also see that there are few other subatomic particles which are in their way and which are blocking the way of the flowing charges. This blockage, what happens? This blockage is offering a resistance to the charges. So the normal electricity would flow very nicely if there is no resistance, but due to resistance there will be a blockage in the flow of electricity. Right? You see, while free electrons are moving inside the conductor, their motion is opposed by the subatomic particles. This oppose in the electron flow is called resistance of the conductor. See, every resistance will not be like this, right? So according to the nature of material, there will be difference in the resistance that they are offering. Clear? Normally, resistance depend on type of material and physical situation like temperature. Temperature, I'll tell you how. And type of material again. If it is a good conductor, very less resistance. Right? You see, those materials which offers less resistance are good conductors. Right? Why they are called good conductor? Why? Because they allow the electricity to flow easily. In which condition they will allow the electricity to flow easily? When there is very less resistance and when the electrons flow very nicely. Now those materials which offer more resistance are called bad conductors. And here you see, I told you that physical situations also affect the resistance. Over here you can see a normal wire, cold wire, the other subatomic particles are not vibrating much and they are not displacing their places. So they give the way to the electrons. They are not disturbing much. But if you see over here a hot wire, what will happen if the wire is hot? The other subatomic particles will vibrate and oscillate so much that they will resist the flow of electrons. Right? So you can see a normal wire, cool wire is allowing the electrons nicely, but if you heat the wire, the resistance will increase, the charges cannot flow properly. Clear? Moving on to some important terms related to this concept. The first important term is resistor. Resistor is a component in electric circuit which resists the flow of electron, which in turn changes the value of current. Right? Every electrical appliance will not work on the same amount of current and voltage. Right? Some of the appliances need very less current, some appliances need more current. So suppose if you have to glow a bulb which will need very less current, and current is coming from the main lines, that is very high value current. So if that high value current is going in that bulb, the bulb will fuse. So what do we need to do? We need to reduce the current going into the bulb. So what we will do? We will just connect a resistor which will decrease the amount of current, and then whatever quantity is required to the bulb, that current only goes in the bulb. Right? So resistor is a component which resists the flow and decreases or changes the current. Variable resistance, right? Variable resistance means current which can change, resistance which can change. It is also called rheostat. It is a device or component used in electric circuit to change the value of resistance, right? It consists of many coils of wire, and very surprisingly you can control how much resistance you want to offer. This device or component can be found in your physics lab. Whenever you have time, you just go and make a visit. Now, after these two components, resistor and rheostat, we will see what is good conductor. It is a material which offers low resistance, that charges can flow easily and current can increase. Right? Till now, when we studied good conductors and insulators in lower standards, we just studied that materials which allow the charges to flow easily. But on terms of resistance, how we can define good conductor, bad conductor, insulator, like this. Materials which offer low resistance. Low resistance means very smooth flow of charges. That means current can increase. So copper. Now poor conductor. Materials which offer noticeable high resistance so that charges will resist the flow and then current can be decreased. Like you see, iron as compared to copper and silver can be considered as poor conductor. More resistance, less flow of electricity. Insulators, materials which offer very high resistance so that charges resist the flow of other charges and it decreases the value and almost negligible amount of current flows. That means rubber, you see, it is an insulator. So just good conductor, poor conductor, insulator, you just have to take care about which material offers how much resistance. Good conductor, low resistance. Poor conductor, noticeable resistance. Insulator, very high resistance. Clear? Now, let us study a new concept, resistivity. Okay. Now, how resistance and resistivity is connected? To study resistivity, we need to understand more about resistance. So, let us see point by point. Resistance of any material that depends on various factors. Just now I told. Resistance of any material is directly proportional to length. And whenever we use directly proportional, you see this symbol. R is directly proportional to L. Resistance is inversely proportional to area of cross section of conductor. Right? Area of cross section. That means whether the wire is thick, whether the wire is thin. So that is area of cross section. But resistance is inversely proportional. So you see R is inversely proportional 1 upon area of cross section A. Right? So R is proportional to L, R is inversely proportional to 1 by A. Now what if we combine both? So combining both, we will have R is proportional to L in numerator, A in denominator. Clear? So R is proportional to L by A. Now we know what is the next step. The next step is removing the proportionality symbol and putting equals to sign along with a constant. So let us do this. R equals to, now you see over here we have a special constant, right? This constant is called resistivity. L by A will be repeated. So R equals to rho L by A again is the formula of resistance in terms of resistivity, length of conductor, cross section area A. But here we have to focus on this constant. This constant is pronounced as rho. Okay, RHO rho. So R equals to rho L by A. Clear? Now let us make the formula of rho by this formula only. So moving ahead, we see R equals to rho L by A. So rho will be doing the cross multiplication. It will be RA upon L. Okay. Unit of resistivity rho is ohm meter. How? You can see over here. R is ohm, area meter square, length meter. So meter and meter will be cancelled. So unit will be ohm meter. Clear? Now resistivity again is a property of the material of conductor. Resistivity is a property of the material of conductor. Insulators have high values of resistivity. Conductors less values of resistivity. Alloys of metals. Alloys, you know, if we mix metals and metals or metal or non-metal, we get an alloy, a mixture. It offers high values of resistivity than their component metals. And these alloys are used in making the heating element of devices like electric iron heaters. I hope you have seen electric iron and heaters. Now, high resistivity, how it helps? High resistivity allows the electricity to convert or to dissipate in form of heat. That is called heating effect that we are going to study in the next few topics and the next videos, right? So you see, this is an example of heater. You can see a coil. These coils are made up of alloys of metals. Whenever you connect it, the current will flow and very high amount of electricity will flow, creating the heat. Okay. Even you take electric iron. So inside of electric iron, you can see this coil, right? Very thick coil, and whenever you switch on the electric iron, it will get heated. How? Due to this coil. Okay, they offer very high resistance to the current, and this resistance converts into heat. So this is the working of heater and iron, right? Next time when you use, you just think about this. Now let us solve a question related to resistivity. So remember the formula, rho equals to Ra upon L. So resistance of a copper wire of length 2 meter and 1.7 into 10 raised to minus 6 square meter area. Remember the wire is very thin. Whenever you see a wire, it is very thin. So that is why 10 raised to minus 6 square meter. Okay. And the resistance value is given 2 into 10 raised to minus 2 ohm. We have to find out the resistivity. So let us make a list of what is given. Length L is given, it is not I, it is L. 2 meter, area A 1.7 into 10 raised to minus 6 square meter. Resistance R is given 2 into 10 raised to minus 2 ohm. What we are finding is resistivity rho. So that is Ra upon L. Putting the values, you see 2 into 10 raised to minus 2. This minus 2 is the power. Please take care while writing. Okay. Into 1.7 into 10 raised to minus 6 upon 2. So 2 and 2 will be cancelled, and 10 raised to minus 2 and minus 6 will mix into minus 8, and 1.7 will remain. So resistivity rho is 1.7 into 10 raised to minus 8 ohm meter. Right? Again I am repeating, this 10 raised to minus 2 and minus 6 is to be written in form of power. Okay. So this is how we can use the formula of resistivity. We have seen the concept of resistance and resistivity. I hope it is clear. If not, please re-watch the video and mention in comments if you have any doubt. And how was the video? We are going slowly topic by topic so that this chapter can be comfortably easy for you, right? And you are giving very nice responses, so thank you for that, and that's it for this video. Have a good day.